Hey guys, welcome to the next lecture on the IIT JAM and the GATE statistics. Today I will discuss about the movement generating functions from this years. Myself Dr. Harish, you can simply follow my YouTube channel. You can find the two playlists. One is related to the PY questions of the IIT JAM, and you can see I have uploaded a few videos on this. Another one is PY questions on the probability and statistics from the CSR net as well as the GATE examination. You can follow these two lectures and the videos and you can learn many more tricks. So as I told you, I have uploaded these previous lectures in my YouTube channel. Now I will cover about this in this lecture. So before I start directly to the movement generating function, I will give you some tips and the remark as well as the shortcut tricks so that you can learn the problem solving approach in a very simple manner. First of all, what is the movement generating function? If you have a random variable x, then the movement generating function is defined like here. For any of the function, you have to check whether the movement generating function exists or not. For example, if I say the movement generating function is 4 over 1 plus t square, 4 plus 4 over this, for example, does it a movement generating function? You can check whether this property is satisfied or not. So clearly say m of 0 is not equal to 1. It means this is not the movement generating function. Second property, you can check it if you have find the movement generating function the c into x, that is a scalar multiplication, then it will be the movement generating function of c of x. Whenever you have to add something, then it's a e raised to power at of these things. And the last thing is, if you have the movement generating function of two independent random variables, then the sum of the movement generating function is the product of this. Before I start with this, you must know about the standard distributions like binomial, Poisson, geometric, and here these are the PDFs or the PMF. Once you know it's a binomial distribution, then you must remember the movement generating function in advance. Like here, Q plus P of this, where P plus Q must be 1. Similarly, if you have the Poisson distribution, you must remember it's the movement generating function here. And if a geometric distribution, you can remember about this property. On the other hand, if you have the continuous distribution like this, you must remember these are my movement generating functions of here. Also, we all know if I put alpha is equal to 1 in the gamma distribution, then it becomes my exponential distribution, and you can see that it is similar of this. The last concept is how you can remember the normal distribution. It is the formula of the normal distribution. Based on this, you can easily find the normal distribution of the z, that is called as the standard normal variate, where mu is my 0, sigma is my 1. So if you closely look about that, there are the three kind of the exponential movement generating function. One is the uniform, second is the normal, and the third one is Poisson distributions. So let's start with this one. So you can simply scan and join my WhatsApp group. We can discuss many more in this lecture. Okay, so the movement generating function, whenever you see the concept of the movement generating function, think about that, what kind of the movement generating function here. It is look like say this form. Fine. So it means your x1 will follows binomial distribution with the n is my 3, probability is 1 by 4. If you compare them, this is my p. If you compare here, what is that? It is my Poisson distribution with the parameter 2. Fine. Now once you know the distributions and they are told as a distribution is identical, independent. So here is x1, 2 up to this n, and for this case x is my 0, 1, 2 and so on. Under what case the probability is my 1. So p of x1 plus x2 is my 1. So can you find the cases? There are the two cases. One case is when x1 is 0, x2 will be 1, or x1 will be 1 and x2 will be 0. There is no other case. Now because of this independent, I can written as a product. What is that? It's a binomial distribution. So n c0 p raised to power 0 q raised to power 3 into Poisson distribution. So e raised to power minus 2, 2 raised to power 1 over 1 factorial. This is 3c1 p raised to power 1 q raised to power 2 e raised to power minus lambda raised to power 0 over 0 factorial. So 3c0 is 1, p, what is the q is 3 by 4. So 3 over 4 power cube, this is 2 into e raised to power minus 2 q square p into q square. So 1 over 4, 3 over 4 into square. So I can see again 4 raised to power cube is common. 3c1 into this again 3 raised to power 3 into e raised to power minus 2. So 3 raised to power 27 over 64 e raised to power minus 2 is my common. So 2 plus 1 is a 3. So 81 is the right answer of this problem. Look at this one. The moment generating function is given to be as e raised to power 3 plus 8t square. How you remember that? Remember, whenever there is exponential part, there are the three kind of the moment generating function. One is the Poisson distribution, second is the normal distribution, third one is the uniform distribution. But whenever you are talking about the Poisson distribution, it is again in the exponential part, but it is not here. So this option is cancelled. Whenever you are talking about the uniform distribution, it is e raised to power t divided by something, but it is not divided. What is the normal distribution is? This. That's why I am asking you, you must remember if you compare them, what does that mean? X follows the normal distribution, mu is my 3, variance is my 16. So I can substitute here, I can convert into the Z. So 4 point this divided by 4 less than Z less than equal to 9.60 minus 3 divided by 4. So what is the right answer of this? You can use your calculator. It is minus 1.96. This is less than, and it is 1.65. I can write this in the CDF form. 1 minus 65 minus 1.96 of CDF. Now it is a greater than of sign, but I need of this. I can subtract them as a 1 minus. It's a minus of the 1.96 and it's a greater than, which are both the same. So 0.25. So what is the right answer of this? It's a 0.975. So it's a 0.925 is the right answer of the problem. Okay, it's a integer value. That means it's a discrete distribution. Fine. So what is the meaning of that? You need x 7 minus 5 2. 2 is less than 1. So this is the case. Okay, so we can apply the moment generating definition. What is that? Expected value of tx. If I open this, e raised to power tx into px. Fine. So now I can compare this. What will happen if I multiply this? The first value will be e raised to power minus. If I multiply them, it is e raised to power minus t plus e raised to power 0, e raised to power t, 3 e raised to power 2t divided by 10. So x will be my minus 1, x will be 0, t of x. I can compare this part. It's a 1 and 2. What are the probabilities? 2 over 10, 1 over 10, 4 over 10, 3 over 10. So you need a x less than 1. That means these two quantities. What are the right answer of this? 2 over 3 plus 1 over 10, 2 over 10 plus 1 over 10, 3 over 10 is the right answer. Okay, again the moment generating function is given to be here. Again it is not a Poisson distribution, it is not a uniform distribution. So it is only, you can see, if I compare this by here, it means it is my normal distribution. So what is that? Mean is my 2. If I open them, it will be my 2 of t square. So if I compare them, sigma square will be my 4. Now I can convert into the z. It will be 0 divided by 2. So what is the right answer of this? Whenever is my half. So B is my right answer. You can see you need only the 10 to 15 seconds if you remember your moment generating function of the standard distribution functions. Okay, look at that. Which of the following is the moment generating function? As I told you, you can firstly check whether m of 0 is 1 or not. This is 1 satisfied. 1 plus 1, 2 raised to power 2 satisfied. 1 plus 1 is a 1 over 4 raised to power n, which is not equal to 1. This option is cancelled. Again, this option is cancelled. Fine. Now we will see about these two options. Now can you think about any of the distribution which work like NC of x? It is a binomial distribution. So if I think about here, you can choose any of the probability, there is no worry, but make sure that it must be constant. and it will be constant only when you consider as a half. You can see if I solve them, what is my k? K will be my half of n, because this value is my half of n. So what is that? X follows my binomial distribution with the parameter n, probability is half. So once you know this, what is the moment generating function? So it's a q plus p e raised to power t over n. So which one is the right answer? A is the right answer, and you can see that. So that's a very simple approach you can think about here. There is one more method. Instead of this, if you don't remember this, I can find the probability of this is 1. So k is a common. So I can see it's a nc0, nc1 up to ncn. It is my 1. So what is that? It is my 2 raised to power n is my 1 by using the binomial expansion. So it is k is my 1 over 2n, and 1 over 2n I can written like this way. I hope you can like, you can subscribe, and you can share this video with your friends too. Okay, now what is that? It's a binomial, it's exponential distribution. Fine? No, it is a Poisson distribution. So x follows my Poisson distribution. What is the probability of less than equal to 1? That means 0 and 1. So I can substitute here e raised to power minus lambda, 0 over 0 factorial, e raised to power minus lambda over 1 factorial. So e raised to power minus lambda is common, inside portion is my here. So now I can substitute here. What is the lambda? Is 3 by 2 e raised to power minus half. You can see it's a hardly 10 second to 15 second if you remember the moment generating functions. Okay, look at this one. Again you can see it is look like here. Fine. So what I can do is I have to return in this power. Can I write 216 in the power of 3? Yes, it's a 6. So I can return as e raised to power over 6. So what is that? X follows my binomial distribution with the parameter 3. What is the p? If you compare them, p is my 1 over 6. Then your target is to find greater than 1. Greater than 1 means that's 2 and 3. Or you can write as 1 minus x is equal to 0, x is equal to 1. So I can substitute here. N is my 3, 3c0 is 1, p raised to power 0 is 1, it's a q raised to power cube. 3c1, p1, q square. So what is that? 1 minus q square I can take as a common, is a q plus 3p, or I can substitute here, is a 25 over 36, it will be q 5 over 6, and 3p is a 3 over 6, so 8 by 6. So what is that? 1 minus 216, and this will be 200, so it will be 16 over 216. So I can divide it by 2, it's a 108, I can divide it by 2 again, it's a 54, I can again divide it by 2, so 2 by 27 is the right answer of this problem. You must remember the moment generating functions. Okay, now look at this another one. What is given to you? X is my random variable with the moment generating function here. Then of this. Okay, what is the nature of the x? Is it a continuous random variable or the discrete? It is not given to you. So it's on you choice with which one you want to consider. So I can simply consider x is my continuous random variable. Then what is the probability of the rational? So rational means a over b, and we all know probability at the single point is always 0. So the right answer of this problem is my A is my right answer. But if somebody asks you, sir, it can be the discrete problem because of this summation sign, then there is no problem. You can think about the discrete. Then what is the probability of x belongs to the q? Because it's a rational number, so probability, assume that it's my alpha. Fine. So that alpha is either the 0 or is a rational number, because probability is always lies between 0 and 1. So it can be either the rational or it can be 0. Fine. Now, How you can find the probability of the rational number? So we all know rational and complement of this is always phi. Rational union of this is always r. So I can find the probability of q is nothing but 1 minus probability of q complement. Fine. So what is the q complement probability? Can you find the q complement probability? Or you can see I can find the probability of the q complement. This will be 1 minus probability of this, that is a 1 minus alpha. Fine. Now alpha is a 0 or the rational. But we always remember that whenever you want to find the probability, probability is always find on the countable space. Fine. Probability is always be founded on the countable space. But you all know q is my uncountable. Probability of the q complement is my uncountable space. So once this is uncountable space, this value must be, what is that? It is not a, because this is again a rational number. So this will not be possible. So it means the rational will not be possible. Only case is my 0 is the again right answer of this problem because of this concept. Okay, look at this another one. Probability moment generating function is given to you. Again it is look like say binomial. Fine. So I have to return this in the form of square, this in the form of cube. Fine. So it is 1 plus 3 e raised to power. So I must need it as a 4. Then only q plus p will be 1. It is 3 plus e raised to power t. Again I need it as a 4. So it means 4 raised to power 2, 4 raised to power 3, 4 raised to power 5. It is 1024. Fine. So it means this is my moment generating function of the x. You can see if I consider this is my y, this is my z. So what is the meaning of that? Moment generating function of the x is moment generating function of y into moment generating function of z. What does that mean? By the using the moment generating function property, x will be y plus z, and it's a product of this. This means y and z are my independent. Fine. Now can you find the distribution of this? So y follows the binomial distribution with the probability 2, sorry, n is 2, probability is 3 by 4. Z follows my binomial distribution with the n is 3, probability is 1 by 4. That's over. Now your target is to find the expected value of the x. That means expected value of the y plus expected value of this. So 6 over 4 plus 3 over 4 is a 9 over 4. Correct answer. What is the variance of the x? So variance of x is variance of y plus variance of z, because they are independent. So what is the variance of the binomial distribution? Variance of the binomial distribution is npq. So 2, 3 over 4, 1 over 4 plus 3, 1 over 4, 3 over 4. So you can see 3 over 16 is a common. Inside is 2 plus 3. So 5, 15 over 16, but it's a 32. This option cancel. X greater than 1. X greater than 1 I can written as x is strictly less than 1. That means 0. So x means y plus z is my 0. So what are the possible values of this? So for here the value of the y's are my 0, 1 and 2 because of this 2, and the value of the z is my 0, 1, 2 and 3. What are the possible pair of this when it becomes a 0? Only when y is equal to 0 and z is equal to 0. Because they are independent, I can written as a product. So what is the answer of this? It's a binomial. 2c0 is 0, p raised to power 0, q raised to power 2. For this case 3c0 is a 1, p0, q raised to power 3. This q is for my here. So what is that? This is 1 over 4 square and this is my 3 over 4 square. So what is that? 1 minus 9 over is a 16 into 16, 256. So it clearly says that it will not be 27 over 1024. This option is cancelled. Look at the last option. I can clear this screen. X is equal to 5. X is equal to 5 means y plus z is equal to 5. So can you find the possible cases? 0, 3 not possible. The only possible is when y is equal to 2 and z is equal to 3. Because of the independent nature, I again multiply them. So what is that? nc2 p square q 0, 3c 3 p cube q. Remember that this p and q is for here and this one is, so what is that? It's a p square, it's a 3 over 4 into 2. This is q, it's a 1 over 4 of q. So it's a 4 raised to power 5 is the below, it's a 9. That means 9 over 1024, but he said 3 over. So this option is also cancelled. Right option is only A is my right answer. Okay, again you can see that it's a very simple. I can return this number as 8 divided by 9 whole square. That means x follows the binomial distribution with the 2 and 1 by 9. This I can return as a 4 over whole cube. So y follows my binomial distribution again with the parameter 3 and 3 over 4. So x varies from 0, 1 and 2 based on this n. Y varies from 0, 1, 2 and 3. Now look at that. X plus y will be 1. What are the possible cases? And they are given to you as a independent. So the only two cases are when x is equal to 0, y will be 1. Either x will be 1, y will be 0. So once they are independent, I can multiply them. So 2c0 p raised to power 0 q square. For this case, 3c1 p raised to power 1 q square. 2c1 p of q1, 3c0 p raised to power 0 q cube. So it's a q square. For this case, it's a 8 over 9 square. 3c1 is 3, p is my 3 by 4, q square is a 1 over 16. 2c1 is 2, 1 over 9, 8 over 9 into 3c0 is 1, is a q cube, is a 1 over 4 cube. So you can see it's a 9, fine. So it's a 64 over 81, 9 over 64 plus 2 into 8 over 81 into 1 over 64. So it will be 8, it will be 4, 64 cancel, it's a 1 over 9 plus 1 over 81 into 4. Fine, is it fine? So one, I can take 1 over 9 is common, so 1 over 36. So 37 over 36 into 9. So let me do it on the calculator. What is the answer of this? 37 divided by 36 multiplied by 9. So the answer is 0.1142 is my. So you can round off them to the two decimal places. 0.114 or 115 is the right answer of the problem. Okay, now you can see about here which of the following is the moment. Again, this exponential part, but if you compare them, it is my here t of b minus t of a. If I choose b is equal to 1, a is my 0, it is similar of this. So it means x follows my uniform distribution of 0, 1. Then your target is to find the value of alpha and beta. How you can find the value of alpha and beta? Again, very simple. I can factorize it. Firstly, 48x square minus 40x plus 3 is my greater than 0. So what is that? It's a 144 and 40. So 36 and 4. Fine. Plus 3 is greater than 0. So what is the meaning of that? 4 will be common. It's a 12x minus 1 and it is a 4x minus 3. Fine. So we all know if x minus alpha, x minus beta is my greater than 0. What does that mean? X belongs to the minus infinity to alpha. Which one is the minimum? Union. Which one is the greater than and comma infinity. So it is x belongs to minus infinity to 1 over 12 union 3 over 4 to infinity. But my domain is only 0 comma 1. So I can write on the 0 comma 1. 1 over 12 will be here, 3 by 4 will be, so it means lies on this case. Fine. Now your target is to find the value of probability, and it's a uniform distribution. So what is the alpha? Probability is lies between 1 to 12 plus probability lies between 3 to 4. Now since it is a uniform distribution, so it is my 1 over 12 plus the range of this, it's a 1 over 4. So it is 1 over 3. Alpha is written as 1 over 3. Now how you can find the beta? Again, I can factorize them. Beta will be here. So it will be, I can factorize them ln x 3 and 2. So ln x plus 3 and ln x minus 1 is a greater than 0. So what does it means? X belongs to minus infinity minus 3, because x will be here, union, it will be 1. So e raised to power 1 comma infinity. So if I write again on this 0 and 1 interval, e raised to power 1 over e raised to power, so it will be like here, and e raised to power 1 is 2.7 something, so that will be outside. The only portion is this one. So beta will be probability of 0 less than x less than of here. So that means it is my this one. So I can substitute here. It is 1 over 3 minus, it is a plus 6. So 16 plus 1 over 3 plus 6 is a 18 plus 1, 19 over 3 is the right answer. Okay, now again you can see it's a discrete random variable. So I can draw the table. It's a x, px. I can compare again with the e raised to power tx into px. So it is 0, e raised to power 0, e raised to power 1, e raised to power 2, e raised to power minus 1, e raised to power minus 2. Probability is 1 over 2, 1 over 12, 1 over 6, 1 over 3, 1 over 4, 1 over 6. And your target is to find the expected value. So this 0, 1 over 6, 2 over 3, minus 1 over 4, minus 2 over 6. So you can see it's a minus 1 over 6 plus 2 over 3 minus, so I can take as a 12 LCM, minus 2 plus 8 minus 3, 6, 2, it's a 2 over, so 1 over 6. So 1 over 6 into 8, 8 over 6, that's a 1.33 is my right answer of this problem. Okay, m is the moment generating functions. Which of the following is not the moment generating function? Or very simple, I can check firstly whether this property is satisfied or not. M is already a moment generating function. That means m of 0 is 1 given to you. If I substitute here 5 e raised to power 0, 1 minus 0, m of 0. So that comes to be 5, which is not equal to 1. This option is the correct option. E raised to power 0, 1 into m0 is a 1. So that is a moment generating function. 1 plus 1, 2, 2, 2 minus 1, m0. Again it's a 1. So m of 0 is again 1. So only A is my correct option of this problem. Okay, which of the following is the moment generating? Okay, fine. Okay, now this is exponential. I can return this number as of, fine. Now do you remember that what kind of the moment generating function is here? If I compare this function by here, what is that? This is the gamma distribution. So what is the value of this? Alpha will be my 5. What is my beta? If I compare them, beta will be 1 over 4. It means x follows my gamma distribution with the parameter 5, beta is 1 over 4. Then the Chebyshev inequality. Okay, so for the Chebyshev inequality, we need a mean and the variance. Fine. If x follows the gamma distribution here, what is the mean of this? Alpha over beta. Variance is alpha over beta square. So can you find the mean is 20. Alpha 5 over 16 is 80. Then the lower bound of this, I can subtract the mean from this. X minus 20 is less than 20. Fine. So remember always, whenever you have of this nature, the lower bound will always be 1 minus variance of x over a square. So I can say it's a greater than, what is the variance is 80 over 400. So it's a 1 over 5. So that is 1 minus 1 over 5 is 4 over 5. So by using the Chebyshev inequality, answer is 4 over 5. So this option cancel, this option cancel. Now by using the Markov inequality, so what is the Markov inequality? There is no need to subtract them. So x less than 40 is always be greater than of 1 minus expected value of x divided by this value a. Fine. So what is that? X minus 20 over 40, that is 1 over 2. Half, 1 minus half is half. So lower bound is half. So this is my right answer. It is wrong answer. So A is my correct answer. I hope you can like, share and comment, on my video. Now look at this. These are the GATE 2022 statistics paper. Now again you can see it's a discrete problem. So I can write this into here. I can compare them. It's a e raised to power 0. X is 1, 2 and 3. Again remember that I have to compare this by this problem. So what is that? It's a 1 over 6, 1 over 3, 1 over 3, 1 over 6. Your target is to find the less than or equal to 2. Fine. Or I can return this number as 1 minus greater than 2, that is 1 minus 1 over 6. So 5 over 6 is my right answer. Otherwise you can simply add them. Again you will get as 5 over 6 is the right answer. How many seconds you are needed? Maximum 15 seconds you are needed to solve the problem. Okay, x and y are my joint moment generating function. Which are the following here? Okay, moment generating function of the x and y is e raised to power s square plus t. Okay, now you can see there are the two different variables. If you think about that, I can compare this problem by here. Fine. You can compare them. In that case, your joint density function will follow the normal distribution. But here, remember that it's the same parameter. Firstly, you can find the moment generating function of the x. How you can find that? Very simple. You can substitute. If I say s is my parameter corresponding to x, t is my parameter corresponding to y. So then I can simply take, because I need to find the x, so I can take t as a 0. So it is my s. I can find the moment generating function of the y by taking s as a 0 and of this. So what is the answer of this? E of 2s square. And from here it is e of t. Fine. So once it will be here, now you can compare this value. So what is the meaning of that? X follows normal distribution, mean 0, variance 4. What is that? Can you find any of this? Again you can see from here it is y. Y again follows the normal distribution with a mean 0 and there is no sigma square. So it is 1 and 0. Fine. Now then your target is to find this probability of this. So I think that's over. I can convert into the z. So x plus 2y. X follows the normal, y follows the normal. This also will follow the normal. What is the mean of this? X has a mean 0, y has this. So this has a mean 2. What is the variance of this? So now you can find the variance of this is variance of x 4 times variance of the y plus 2ab covariance of xy, because they are not given as a independent. Okay, variance of the x is 4. This will be my 0. How you can find the covariance? Expected value of the xy minus expected value of x, expected value of y. So how you can find the expected value of this? So that I can do it. Firstly, partial derivative of this moment generating function at s is equal to 0, t is equal to 0. That's the moment generating, that's the expected value of this. So firstly I can find the derivative with respect to t. So what will happen? If I write for you, What is the partial derivative with respect to t? It is same into 1. Now I can partial with respect to s. It will be 2s, sorry, 2 into 2s of here. Fine. So what is the value of the at s is equal to 0 and t is equal to 0? This is 0. So this value will be 0. E of y will be 1. This value will be 0. So whole will be 0. So variance is my 4. Fine. Now what is the remaining side? That's over. Your target is to find the probability of, I can convert into the z. Z is x minus mu over standard deviation. So what is that? Probability is minus half. So minus 0.5. I have a plus 0.5. I can return this number is 1 minus probability of plus 0.5, and plus 0.5 is 0.6915. So it is my 0.851. It's a point of, sorry, it is my 0.3185. So and your target is to find the 2p plus 1. So it's a 2 into 3185 plus 1. You can do it calculation, you will get the right answer. Remember, this is the concept. When you have the joint density function, you again the concept is similar. You can find the corresponding the moment generating function of the x by taking y, that is s as a t as a 0, moment generating function of the y keeping s as a 0, and compare with the same approach. Okay, look at this one. The moment generating function is given to be here, e raised to power t minus 1 over t. I can separate it, and this will be here. Fine. This is the moment generating function of this. So do you remember that? What is the distribution of this? You can see e raised to power t b minus of a over, what is that? This is, if I call this is my y, this is my z. So y follows my uniform distribution with 0, 1. Z will follows my, which distribution is here? This is here. That is a exponential distribution, or otherwise you can see t over lambda raised to power minus alpha. It is alpha will be 1. That is the exponential distribution. So z follows my exponential distribution. Now, so it means this is the moment generating function. So that means x will be my y plus z, and moment generating function of the x is a product of this. It means y and z are independent. Fine. Now that's over. Now what you want to calculate? X is greater than 1. X greater than 1 means I can say x is less than 0. Sorry, less than 1. Because they are the continuous random variable, we can't say. So x means y plus z is less than 1. So how you can do that? It's a double integration, because it's a joint density function. Because they are independent, what is the joint density function of this? It's fy into fz. Fy will be 1 over 1. It is e raised to power minus z. Fine. Dy dz. So what are the limits of this? Because it's a y is my 0 to 1 and z will be my 0 to infinity. So I can return here is z firstly, z and then y. But you can see that I need it to be sum should be less than 1. So this value must be start from here. So here is, so you can correct the limit here. So what is the minimum value of the z? Because the exponential distribution is a 0. Fine. But what is the upper limit? Because you can see the value of the z is, the maximum limit will be my 1 minus y. Now that's over. Now you can solve it. E raised to power minus z over minus 1 from 0 to 1 minus y. So what is that? It's a e. I can substitute here. It is minus. I can take it as a, this one is a here. I can adjust this. If I substitute here, it is y minus 1 of minus 1. So can you integrate them? Now I think it's a very simple. It will be 1 plus integration of this will be same. It will be y. So what is that? 1 plus e raised to power 0 minus 1. If I substitute 0, it will be e raised to power minus 1 plus 0. So 1 will be cancelled out. It is a 1 minus 1 over e. Fine. So 1 over 1 minus e is the right answer, or you can simplify it 1 minus 2.718. So once you can do it little bit more calculation, if you use your calculator, it comes to be 0.63 is your right answer. Look at this another one. What is given to you? X and y are the joint two moment generating function of the x is my m of t. Moment generating function is my here mean and this. Okay, your target is to find the variance of y. We all know we can find the variance of this. Fine. Now your target is to find the relation of EY. I think it's very simple. How you can find the E of y? That's a one-time derivative of moment generating function. So what is the moment generating function of the y is h. So I can say it is my 1 times derivative. What is the E of y square? It's a 2 times derivative at t is equal to 0. Fine. So I can substitute this value. What is the first time derivative of this? So I can use this product rule. It's a 6 over 4 e raised to power 2t into m plus 3 over 4 e raised to power 2t plus 1 over 4 into m dash. Fine. Now it's again a 3 over 2. So what is the value of the h dash at the point 0? It will be my 3 over 2. M of 0 will be 1. It will be my 1 m dash of 0. So m dash of 0 is, what is m dash 0? M dash 0 is nothing but expected value of the x, because m is the moment generating function of the x and the mean is given to you as 1 by 2. So it is 3 over 2 plus 1 over 2. So that value will be my 2. Fine. Now your target is to find the x y square. So that is a second derivative. Oh, I remove it. What's the first derivative? I again needed to calculate. It's a 3 over 4 e raised to power 2t plus 1 over 4 into m dash plus 6 over 4 e raised to power 2t into m. This is the first derivative. Now what is the second derivative is? Again it's my 6 over 4 e raised to power 2 into t is a m dash plus the same value m double dash. Again this is my 12 over 4 e raised to power 2t into m plus 6 over 4 into m dash. Fine. Now at the point t is equal to 0, this value will be my 3 over 2. What is the m dash? First derivative is expected value of the x. It comes to be half. This value is here. It is my 1. What is the m double dash is? Expected value of x square. How you can find it? Because the variance is given to be here. So I can find this value as from the variance formula. So it is a 1 over 2. It's a 3. This is 1. M of 0 is my 1. It is 3 over 2. What is the m dash? Is the expected value of the x is come to be half. So what is that? It's a 3 over 4. It's a 3 over 4. So right answer is 3 over 4 plus 1 over 2 plus 3 plus 3 over 4. So this will be my 3 over 2, 3 over 2 plus 1 over 2 plus 3, 4 over 2 is a 5. So this is my 1 is the right answer of this problem. Otherwise you can check your calculation, if because it's an integer, if you can check your calculation, but I tell you the approach. I think the answer will be 1 is the right answer of this problem. Okay, look at this another one. It's a GATE 2023. Okay, probability density function is given to be here, x factorial. Oh, that's very simple. Okay, fine. This is the probability density function. Do you remember any of the distribution which fall under y minus x factorial? This is just like say here. Do you remember that? It's a binomial distribution. So I can firstly break this portion. I can write here is x factorial y minus x factorial. So this is NCR. So I can multiply this by y factorial divided by y factorial. Fine. Now look at that. What will happen if this is the exponential, it look like exponential distribution. Fine. So now here is the y, so I can multiply this by lambda is my 2 raised to power y. So I can divide also by 2 raised to power y. Fine. So this value I can simplify, this is my y factorial. Fine. What is that? This is a NCX, half of the y. I can return this number as half of x, half of y minus x. So that's a joint density function. What is the meaning of that? This is my y. It follows my Poisson distribution with the parameter 2. What is that? This is my conditional probability. X condition y follows my binomial distribution with the n is my y, probability is half. Fine. Now you get the information about the distribution. Now you can check about that. Expected value of this. What is the expected value of x condition y? This is n into p, and n is my y is equal to 4. So it's a 4 over 2. That is my 2 is the right answer. The moment generating function of the y. So y is my Poisson distribution. So what is the moment generating function of the y? E raised to power lambda, e raised to power t minus 1. Lambda is my 2. So you can see this is also the correct answer. Moment generating function of, okay, what is the expected value of the x? But we don't know the distribution of the x. But anyhow, as I told you, again the shortcut tips. If y follows the Poisson distribution with the parameter lambda, x condition y follows the binomial distribution with the parameter n comma p. This implies x follows my Poisson distribution with the mean lambda into p. So what does it mean? X follows my Poisson distribution. What is the lambda? Is 2 into 2, 1. Fine. So from here he said expected value is 2, but Poisson distribution has expected value. This is the wrong answer. Okay, look at the last option, the joint density function. You can check it easily. Can you find the moment generating function of the x? How you can do? I can choose v as a 0. If you substitute v as a 0, it will be e raised to power 0, 1. Fine. So it will be e raised to power minus 1 plus e raised to power u. What is the moment generating function of the y? I can take v as a 0. So v as a 0 is a 2 times 2. I can take as a common e of v minus 1. What is that? This is the moment generating function of Poisson distribution with the parameter 1. So from here also you can see that x follows the Poisson distribution. If you don't remember this trick, then you can also see about here. So x follows my Poisson distribution, y follows my Poisson distribution, and both are satisfied. This is again say Poisson distribution of the 2, this say Poisson distribution of 1. So this option is my correct statement. And this option you can discard either by this shortcut tricks, or you can see this the Poisson distribution. So mean is my 1, but he said 2. This option is cancelled. So this is the way you can solve the moment generating functions in a simple manner. I can come back on this again lecture on the joint density function on the gate as well as the IIT JAM in our next lecture. Till now you can simply like, share and comment on video. Best of luck students. Happy learning.